In this last section, we're going to walk through some proofs. First page of this section has a diagram of two lines cut by a transversal and some theorems. Okay. We have the alternate interior, exterior, corresponding angles, the vertical angle theorem, consecutive same side interior, consecutive same side exterior angles. These are all theorems. We've talked about them before. So alternate interior, exterior, corresponding, those and vertical, those are all showing congruency of angles. The top three in particular, if you can show that angles congruent, these pairs of angles are congruent, then you can also show that your lines are parallel, and we'll get to that later on. Following the theorems, we have some definitions and then properties, and these are going to allow us to complete the proofs in today's section and future sections. Okay. So at the top of this page, you have a diagram that kind of summarizes the theorems on the front page. Okay? If I know angle 1 and A are congruent, because they are corresponding angles, then lines A and B are parallel. If I know 4 and 6 are congruent, these are alternate exterior angles. So if alternate exterior angles are congruent, again, my lines are parallel. Alternate interior, this should be 3 and not 5. 3 and 5 are alternate interior angles. If they are congruent, then my lines are parallel. And then if I know 2 and 5 are supplementary, then that also tells me that my lines are parallel. Same thing for exterior. We don't have it in there, but consecutive exterior angles, if they are supplementary, then the lines are parallel. And then the last thing here is don't forget about your vertical angles. Vertical angles are always congruent. It doesn't have anything to do with making lines parallel, but it can make the pairing up easier in your proofs. So let's go through example 1. You'll notice that this proof is completely filled out, and so I'm just going to walk you through it. So we are given that angle 1 is congruent to angle 2, angle 1 is congruent to angle 4, and we want to prove line DE is parallel to line GF. Okay? So the first thing I'm going to do is mark my diagram. 1 is congruent to 2, and 1 is congruent to 4. So as always, what you're given is the first thing you put under statements, and your reason is given. All right? If 1 is congruent to 2 and 1 is congruent to 4, then 2 is congruent to 4 using the transitive property. All right? Well, if 2 and 4 are congruent, these are alternate interior angles. If my alternate interior angles are congruent, then the lines that are cut by the transversal are parallel. And so line DE is parallel to line GF. And that is your first geometric proof.